factor. Okay, as you may have already know, factor is actually an object with magnitude as well as direction. The notation for factor actually varies. Some people will just write down letter, either singular or maybe two letters. But the notation is actually a straight line above the letter, or some people use the arrow notation, by giving it above the letter. Because we have average, to differentiate between factor and average for the rest of our PBA course, then we will use the arrow notation instead. So if you want to write down a factor as already demonstrated here, v factor, I write it as v with a straight arrow pointing right. If I want to create a factor, then we will denote it something like this. Instead of a, this one is average, and this one is factor. Okay, factor may be formed from 2 points at minimum. So if we have point A and point B, we can actually form two factors, either from A to B or from B to A. Factor from A to B is written as AB with the arrow notation. So the representation of factor elements, there are actually many ways to represent factor elements. We only learn one so far. But later I will tell you about how to represent factor in many other ways. So the elements of a factor for now may be represented as comma separated numbers in brackets. With respect to its dimension. So if you want to represent a two-dimensional factor, then just write down x comma y. If you have a three-dimensional factor, then write down in brackets x comma y comma z. Maybe later if you have a four-dimensional factor, well, we don't learn it here. Just write down x comma y comma z comma w. And then factors with a single lowercase letter, like my a factor here. The origin of any factors with a single lowercase letter, is from the center of the coordinate system. So if it is two-dimensional factor, then my a factor actually originates from 0.0. 0 x equals to 0 and y equals to 0. For 3D factors, then it originates from 0, x 0, y 0, and z 0. Okay, about the factor elements, if it is not factor that originates from the center of the dimension, so if we have 2 points, then we can form a factor AB. And for the elements, you can calculate by this formula. The factor AB is B minus A. Don't forget that the calculation is switched around. So N minus start, not start minus N. Please remember this. If you have the factor AB, then the elements are actually B minus A. Or we can expand it. So the x element for the factor AB is xb minus xa. Then for the y element is yb minus ya. So for example, if we have a if we have a point A at 2, 3, x2 and y3, and B is at the position x5 and y is 6, then we have the factor AB, xb first, 5 minus xa, which is 2, and then for the y component, yb, it's 6 minus ya, 3. Then we get the components of vector AP is x equals to 3 and y equal to 3. Okay, let's have another example. Let's see, can I move? Oops. Okay, I can move down here. If I have my point A, let's say it's in 3, 5, and then I have my point B is 10, 8. What are the components from vector AP then?
Is it 10 minus 3,
Mm-hmm.
comma 8 minus 5?
Yes, you are correct. Yeah, so remember B minus A. So for the x component, 10 minus 3,
3,
and then 8
comma 8
minus
minus 5.
5. So you will get
7 minus
7
3.
and
7, comma 3.
7, 3. For the BA then, what about vector BA?
3 minus 10.
3 minus
8,
10.
then it
Yeah.
means A minus B.
Yes. So
3 minus 10,
3 minus 10 and
comma 5
5
minus
minus 8.
8.
So you'll get,
Oh, is it
oh, sorry. Why I
10
wrote
or
7? 3 minus 10.
10? It's minus 7 and minus 3.
Minus 7 and minus 3.
3.
Yeah, so remember n minus start. Whoops. Okay, and we have a vector magnitude, which is denoted by two straight vertical lines, yeah, enclosing the vector itself. Yeah, the vector magnitude, or sometimes we call it length. Yeah, magnitude is the same as length. It is calculated by taking the square root from the sum of its elements squared. Let's just take a look at the example. Yeah, for a 2D vector, the magnitude is actually the square root of x squared plus y squared. If you have 3D vector, then the vector magnitude is actually the square root of x squared plus y squared plus z squared. So for example, let's say that I want to calculate the length of vector AB. Then we can calculate it by taking a square root of the x element squared, 7 squared, plus the element of the y, 3 squared, which is the square root of 49 plus 9. The square root of 58 is 58 square root 7.62. Yeah, that's how you calculate the magnitude of a vector. And then we have a unit vector. Yeah, unit vector is a vector which magnitude is exactly 1. Yeah, that's why they are called unit vectors. Some also calls it a normalized factor. Yeah, if you remember from the last week, yeah, if, what called normal is something that ranges between 0 and 1. Yeah, so it also called by the term of normalized factor. And actually in Unity, we have a normalized function later. Yeah, you can try it by yourself. So a unit factor is denoted by a lowercase letter or the two letters. Yeah, if you have a factor that originates from point A to point B, then you use AB. Replace the arrow by a circumflex, or usually let's just call it head. Yeah. So I will call this A head instead of A circumflex. Yeah, it's too mouthful. Right? So A head is something like this. This is a unit vector. Physics usually use the unit vector to represent directions. So x hat means the movement in a x direction, y hat movement in y direction, z hat the movement in z direction. We can convert any factor into a unit vector, or we call normalize a factor, yeah, into becoming the unit vector by doing something like this. Yeah, every element of the vector is divided by its length. So, for example, let's just use this, yeah, because we have already calculated the length of AB, although it's not a whole number. If I want to form a unit vector of AB, which is AB hat, then we can calculate it by divide every elements of the vector, which is dx is 7 divided by 7.62. And then for the y component is again 3 divided by 7.62. Yeah, we can calculate this 7 divided by 7.62 is not 1, 0.92. Then 3 divided by 7.62 is like 0.39. Yeah, I'll leave you to test yourself the length for the unit vector AP. Yeah, it should be 0.92 squared plus 0.39 squared. If you calculate it correctly, you will get 1. Yeah, maybe let's try it in here. 0.92 squared plus, did I hit plus? 0.39 squared. Oh, no, 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 no. Let me try it again. 0.92 squared plus 0.39 square. The result is something like this. Then we take a square root. 0.999. If we round it, then you will get 1. Yeah. So a unit vector has the length of magnitude of 1. So after we know about unit vector, yeah, using unit vector, a vector can also be denoted or represented by algebraic notation. Something like this. A is xa times x hat plus ya times y hat. Yeah, so I have this AP factor, which is 7.3. Yeah, I can write it down as, instead of 7.3, I can also write it down as 7x hat plus 3y hat. This one is algebraic notation. Or if you like matrix, yeah, you can also represent it with a matrix notation. Yeah, A is the square brackets for matrix. Yeah, and the rows just put the unit vector elements. Yeah, x hat, y hat. If it is a 3 dimension, then add z hat. And for the second row, just put all the elements. Yeah, so here my AB vector can also be represented in matrix form as x hat, y hat, 7, and 3. This one is matrix notation. Yeah, so you have three ways to express a factor by using a comma delimited numbers like this. Yeah, I think this is simpler than the others. Yeah, but you can find algebraic notation for factors using x hat and y hat, and you can also represent it with a matrix notation like this. Yeah, for now, let's just use a comma delimited numbers. Yeah, it is the simplest way to represent a factor. Okay, about the operation of the factor, yeah, we can call it like arithmetic operation for a factor. We can add two factors. If I have two factors here, a and b, then it can be added to form a plus b. Yeah, just add the elements of two factors respectively. Yeah, so if you have a plus b, then xa plus xb and by a plus yb. How to add a factor? You just put the factor a, yeah, then put the starting point of the factor b at the end point of factor a. Then you take or form a line from the starting point of a to the end point of b. You will get a new factor a plus b. The factor addition is commutative, yeah. So that means that a plus b is actually the same as b plus a, as the image suggests here. Yeah, if I perform b plus a instead, so I have a b factor. Yeah, I can move this b factor into here without changing its direction and its length. Yeah, obviously you see that these two b factors are the same. Yeah, so I start with b, then I add my a factor, then I will get a plus b is the same as performing a, then b first. Yes, we call this a commutative property of factor addition. For the subtraction, however, yeah, we can subtract two factors a and b to form a new factor, but the calculation is something like this: xa minus xb and ya minus yb, and it is not commutative. Yeah, a minus b is not the same as b minus a. And a factor can also be multiplied by a scalar number to increase its magnitude. Yeah, I have factor a here. If I multiply it by 3, then I'll get 3a. Yeah, if you calculate the length of this factor 3a, then you will get the length is actually 3 times the length of a factor. Yeah, if we have r, which is a scalar number here, and multiply by the factor a, then you can simply multiply its elements with r. So rxa and rya. If you multiply a factor with a negative number or negative scalar, then the direction is reversed. Yeah, so I have my a factor here. If I multiply it by negative 1, the direction will be reversed like here. Yeah, so this is a negative a factor. Okay, so I guess that's all we need to know regarding to the factor. Yeah, at to this point, we will use everything starting from the unit factor, the factor length or magnitude, then addition, subtraction, as well as scalar multiplication. Yeah, if you remember from your high school, we actually still have two other operations, yeah, the dot product and cross product, but we won't use it during the rest of this PPA course. Yeah, so uh, we can simply stop here for factors. Any questions before we continue? I guess not, yeah, for now.
Oh, yes, sir. No question.
No questions, yeah, cannot. Okay. Um, yeah, great then. If not, then it's my turn to ask you. Okay. Please calculate the magnitude of these factors. I have a k factor here. The element is 6 and 8. What is the magnitude of factor k? You can
Is it
actually answer
10?
this without calculating. How much, Gabriel?
10, sir.
10. How do you get 10?
Square root of 6 square plus 8 square.
The square root of 6 squared plus 8 squared. 6 squared is 36. 8 squared is 64. Then you'll get the sum is 100. Yeah, 100. The square root of 100 is 10. What about L? It's not a whole number, obviously. Okay, let me point one of you to calculate the magnitude of L. Let's say Michelle, what is the magnitude of factor L? The square root of 202. Okay, let's say the, the square, 9 square is 81. 11 square is 121. 121 plus 81 is 202. Then you'll take the square root of 202. Yeah, okay, you are correct. The second problem, normalize these factors into unit factors. For A, I have the factor A of 4,8. Please normalize to unit factor for A. Three square root of 2. Okay, I must calculate it. How did you get 3 times square root of 2, Michelle? Six. Wait. 6, 9, and 8, 11. How did you get 6, 9, 8, 11? It is, they are, let's see. Oh, did you use factor K and L? Please just use this factor, yeah. I have the factor A 4.8. Please normalize a factor. Yeah, so you will need to calculate a hat. Okay, that's fine, Michelle. Let's see. Gilang, have you calculated the A hat or the unit factor for A? Can you
it
instruct
was
me how to calculate it? If I have, let me prepare my whiteboard first, yeah. Okay, I have a factor A of 4 and 8. Instruct me how to normalize A factor.
we need to make it like I mean 4 square, like the root of 4 square plus 8 square.
Okay, what do you actually calculate? What are you calculating for the square root of 4? What it is actually? You are
It
calculating
wasn't
this, right?
migrated.
You are calculating this, yeah. What is this?
Yes, sir.
What is this actually?
That's the I think so.
Yeah, the magnitude of factor A, yeah. So, yeah, please continue the instructions for me. After this, then what shall I do?
So 16 plus
16 plus
16 plus 64
which equals to
root 80.
square root of 80. Then
We just need to make it. How is it?
so do you continue or do you stop here?
If we continue, it will be like 2n square 20. 2
2n
times
like
square
this.
20. Yeah, like that. Sir.
Okay, how did you get 2 times 2 square times 20 square?
4 times 20, but so like the square root of 4 times square root of 20.
Okay, let me continue here, yeah. The 4 times 20 like this.
Yes, sir.
Okay, but I think you can actually simplify this 20.
So 4 and 5.
So you get 4 times square root of 5.
Yes, like that, sir.
Okay, then what else do I need to do to calculate the unit factor A hat? After you have got this magnitude, then what shall I do?
So from the 4, like from the A again, we put it like a 4 per 4 times square 5.
Okay, so you are actually performing this, yeah?
Yes, sir.
4 divided by 4.
4, yes, like that, and then the 8 as well.
8 divided by
4
4
square
and
root
4
5.
times square root of 5. Yeah, I think you can simplify this yourself, yeah?
Yes, sir.
Can you?
Yes.
No. Okay, then. Yeah, so you will get, I think, 1/5 square root 5 and 2/5 square root of 5, if I'm not mistaken. Yeah, it should be. Anyone else get a maybe different result? Everyone has the same answer? So you all agree with Gilang's answer, yeah? The unit factor is 1/5 times square root of 5 and for the x element, and for the y element is 2/5 times square root of 5.
Yes, sir.
Okay, nice. It's the same, or maybe you calculate this by calculator, then yeah, it should give you the same result, I guess. Okay, then what about B? Oops. Anyone wants to volunteer how to calculate the unit factor of B? If I have B equals to -5 and 7.
It is -5
Mm-hmm.
per square root of 74, comma 7
Mm-hmm.
per square root of 74.
Square root of 74, yeah? Okay, let's see. We have B is -5 and 7, so we have the magnitude of B is square root of -5 squared plus 7 squared, which is 25 and 49. You'll get square root of 74, yeah? Am I correct?
Yes, sir.
Okay,
Yes, sir.
so the unit factor for B is actually -5 divided by square root of 74 and 7 over square root of 74. Yeah, please simplify this yourself. I think you can just use calculator. Yeah, 74 is okay. Can we simplify this? If I divide it by 2, I will get 37. Oh well, I guess it cannot be simplified, so just use calculator, yeah, for this one. Okay then, so I guess you have completely understood, yeah, how to calculate the magnitude of any factors and also normalize any factors into unit factors. So I guess, do you have any questions about factors, what we have learned so far? I guess not yet for now. Yeah, should you have any questions later, then you can always chat into the Hangouts group chat, yeah? Okay, now the third part is actually the unity time. So I have provided the what is it? Yeah, the playlist, the YouTube playlist for you. You can just start from PBA hands-on. Yeah, for PBA 2.1 and 2.2. For the raw, if the title says raws at the end, then it is actually the recording from the last semester. Yeah, you can safely skip any raw videos. Yeah, just start at this one, PBA 2 hands-on, kinematics in Unity. You can, I will explain it step by step. Yeah, still step by step. You can just follow it. And then before that, I will explain for the exercise. Yeah, you have homework, which is due next. Let's see, next week. Yeah, next week, the 26th of August, before 1 p.m. Please do this exercise. There is an animation here. You can refer for the final result of this homework. Yeah, and I have provided some hints for you as well. If you still have any questions, any difficulties, then just ask me in the Hangouts group chat. Yeah. Okay, so for now, I will leave you to do the third part by watching the YouTube videos. Yeah, I will stay here for the rest of this class until 15:30. So I will still be here for 1 hour. Yeah, but for now, you can leave this Google Meet first. Yeah, because you will need to start Unity, starting Visual Studio, and I think starting your browser also to watch the video. Yeah, it may take quite a lot of RAM from your computer, so you can stop the Google Meet first. Yeah, if you have any questions, you need to show me something, you want to present something, yeah, maybe for troubleshooting, then just go back here, then I will be more than happy to answer your questions. Yeah, but of course, if you want, you can stay here also.